Students, take a look at this beautiful competency based question from chapter 4. We are doing a series of competency questions and this is question number 13 of that series. If you have not watched the previous questions of this series, you can check the link in the description box. So let's start this question number 13 of the competency series for ICSE Class 10th. This is from 4th chapter based on moments. A non-uniform beam of weight 120 Newton pivoted at one end is shown in the diagram below. So you can see this is about a non-uniform beam. Okay. And you can see this non-uniform beam diagram is also given. This non-uniform beam is wider at one end and narrower at another end. Very good. The center of gravity is also shown in the figure and the weight, which is 120 Newton given in the question, that has been also shown here. Obviously the weight should act at center of gravity only. That is very normal. So 120 Newton has been shown vertically below center of gravity. Okay. Now the question is asking, calculate the value of F. F is a force. You can see here. The F has been shown with an upward pointing arrow. So F is acting upwards, vertically upwards. We need to find the magnitude of F or value of F to keep the beam in equilibrium. Okay, so what should be the force F so that the beam is in equilibrium? So if the beam is in equilibrium, we need to use principle of moments, which says anti-clockwise moments must be equal to clockwise moments. Only then this beam would be in equilibrium. So if the beam must be in equilibrium, this condition must be fulfilled. Anti-clockwise moments must be equal to clockwise moments. Now use our common sense. Let's use our common sense and let's see that this is the pivot, right? The pivot has been shown very clearly in the diagram. So from the pivot, which force about the pivot is producing the clockwise moment? The clockwise moment. So if you see this 120 Newton, this 120 Newton is trying to rotate this beam in clockwise direction about the pivot. The pivot is here. So it's trying to rotate the body in the clockwise direction. Simple. So very easy that this clockwise moment is because of this 120 Newton. So let's calculate this clockwise moment and let's write below clockwise moments what is the value of clockwise moment. So that is 120 Newton multiplied with the distance of this 120 Newton from the pivot. So it is already given in the figure that this distance is 0.20 meter. You can see it is written over here at the top. So that distance is given. This is what? Which distance? This is the distance of this 120 Newton from the pivot. Perpendicular distance of 120 Newton from the pivot. So 0.20. So we have calculated the clockwise moment. Now we need to calculate the anti-clockwise moment. Now anti-clockwise moment is because of this F force, which is acting vertically upwards. So this F is trying to rotate this beam in anti-clockwise direction. So let us write the anti-clockwise moment. So F multiplied with now distance of this force from the pivot. We always calculate the distance from the pivot. So should we take 0.80 meter? No, this distance is from center of gravity. This 0.80 meter is the distance of this force F from center of gravity and not from pivot. So we need to take from pivot, this whole distance we need to take. So what is the total distance? So this particular distance is 0.20 meter. This distance is 0.80 meter. So 0.20 plus 0.80, this total distance is 1 meter. We add both of these distances. From here to here it is 0.80 and from here to here it is 0.20. So 0.8 plus 0.2 is 1. So F force is at a distance of 1 meter from the pivot. Yes, that is it. Now our thing is done. So force F comes to be 24 Newton. This is the answer. This is the value of the force that we need to put. I hope you have enjoyed this question. A wonderful question, right? Now you need to be careful if this distance is extended to this particular pivot. In some books they have shown that this distance, the entire distance is 0.80. So in that case you will take 0.80 instead of 1. But in my case this distance was till center of gravity 0.80. So I added 0.20 extra to get it 1 meter. Okay, I hope there is no question. If you have doubt here, again you can ask me in the comment section, and do subscribe to the channel and press the bell icon if you have not done it yet. See you all in the next video.